Imagine a triangle. Now imagine three lines inside a triangle meeting at one perfect point, like best friends meeting at Jollibee after failing the exams. Congratulations! You've just witnessed Ceva's theorem in action.
Hi guys, we are the Ceva squad.
And for today's video, we will be discussing about Ceva's theorem. We will talk about how powerful points and portion ratios are. So what is Ceva's theorem? In simple terms, if you take a triangle, let's call it triangle ABC, and you draw lines from each vertex to the opposite sides, those lines are called cevians. If all those cevians meet at a single point, Ceva says
BD over DC times CA over EA times AF over FB equals 1.
If that equations look scary, don't panic, it's organic.
Just remember, if the ratios multiply results to 1, the lines meet at one point. Well, if they don't, the lines are like your group mates during projects, never meeting.
For example, we have triangle ABC where points F, D, and E lie on sides AB, BC, and CA. The given segment lengths are AF is equal to 6, FB is unknown, BD is 4, DC is 2, CE is 3, EA is 9. Since the lines AD, BE, and CF met at one point, we can use Ceva's theorem. So Ceva's theorem formula states that AF over FB times BD over DC times CA over EA is equal to 1. We can use this formula to help us find a missing segment when the other parts are known. First, we need to substitute all the given values into the formula. So we have 6 over FB times 4 over 2 times 3 over 9 equals 1. Next is simplify each fraction to its lowest terms. So the equation becomes 6 over FB times 2 times 1/3 equals 1. Then multiply the constants. 2 times 1/3 is equal to 2/3. So the equation becomes 6 over FB times 2/3 equals 1. Then multiply both sides by its reciprocal, which is 3/2. These cancel 2/3 and the equation becomes 6 over FB equals 3/2. So now we cross multiply. 6 times 2 is 12 equals 3 times FB. Then divide both sides by 3 to isolate segment FB. Then we solve for FB, so 12 divided by 3 is equal to 4. Therefore, the missing segment FB is equal to 4 units.
Let P be an arbitrary point in the triangle ABC. Extend AP to the opposite side BC where they intersect at point D. Similarly, let PB intersect AC at E and CP intersect AB at F. The theorem states that the product of AF over FB times BD over DC and CE over AE is exactly equal to 1. To prove this, we can use the similarity of triangles. Construct a line from C parallel to AD which intersects BE at G. Similarly, construct a line from B parallel to AD intersecting CF at H. Let their intersections be G and H. Angles AFB and BFH are equal and angles ABF and BHF are equal as they are alternate angles. Thus, all the angles inside triangles AFB and BFH are equal and they are similar triangles. Thus, AF over FB is equal to AP over HB. Next, angles CHB and CPD are equal as they are corresponding angles. Obviously, angles HCB is equal to PCD. Thus, triangles PDC and HBC are similar. Therefore, BC over DC is equal to HB over PD. Another, angles CGB and DPB are equal as they are corresponding angles. Angle GBC is equal to PBD. Thus, triangles PBD and GCB are similar. Therefore, BD over BC is equal to PD over GC. Angles CGE and EPA are equal and angles GEC and PEA are equal. Thus triangles GEC and PEA are similar. Therefore, CE over AE is equal to GC over AP. Using similar triangles, we have obtained four ratios which we can then multiply together. BC cancels out on the left side and all terms cancel out on the right side, leaving us with the intended result. Thus, the theorem has been proved.
It's named after Giovanni Ceva, an Italian mathematician from the 1600s. Some people believe he invented this theorem to impress his classmates. Honestly, it worked! Still impresses students today. So, in summary, Ceva's theorem states the lines from each vertex to the opposite sides are concurrent if and only if the product of ratios equals 1. It's simple, powerful, and just like a good group project, everything works, only if everyone contributes perfectly.
So next time, if you see triangle with lines meeting, don't say wow, say Ceva's approved.